In this video, I'll go over stacks and answer what is a stack, when to use a stack, as well as how to use it, and some practice using stack operations. Stacks are basically known for behavior of LIFO, which is last in, first out. What this means is that the last element that's being pushed to a stack would be the first one out when we pop that element from the stack. So imagine we have a stack of dishes, right? The last dish that you push into the sink would be the last one out. So there's also a synonym that's used. So we have LIFO, which is last in, first out, and there is first in, last out. So those are both equivalent. It just depends on which element you're beginning with when you're referring to the stack. So the last in, this is the last element in, is the first one out when you wash the dishes. But the other one tells you that the first in, which is this one, it's the first because you put it first in terms of the stack, is the last one out. So you take this one out, this one out, this one out, this one out, and then you get to this one. So this is basically the behavior of the stack. And it is data structure in C++. It's an ADT that's implemented using DEX, which is a double-ended queue that is used in many examples, like the undo redo operation. So if you ever use the undo redo buttons on your browser, those are implemented using a stack. So you have a stack of your browsing history. So let's say this is the top one, which you're currently at. Let's say you're at here, this is YouTube. And previously you were using, let's say, Facebook here. So let's write them down. So YouTube is Facebook. And then here's some other websites you're using. So if you undo, you go back to this stack is popped out. So YouTube is popped out, and then your top one, which you'll be redirected to, is Facebook. And then if you redo, this is pushed back into the stack. So this is the top element now, and you're back to your YouTube page. This is just one example of how stacks are used. It's also used when you're typing, when you undo code, or a line when you're texting. So it follows the same operation. Now, stacks are ADTs. They are implemented using double-ended queues in C++, but they can also be implemented using lists or vectors. For this reason, when we deal with stacks, we have a set of operations. Those are abstract operations that we use to help us work with data, but we're not sure about their time complexity or how they're implemented. But we're sure that they will all follow the same operation that we just discussed, which is last in, first out, or first in, last out. Those are again equal in meaning. So when do we use a stack? We have the following operations that are helpful, which are push, pop, size, empty, and top. This is also known as peek in other languages. So those operations help us add to the stack. This one, remove, stack, and this one gives us the size of the stack, and this is a Boolean. It usually returns 0 or 1 in C++. If empty, so if it's empty, it returns true, which is 1. But if it's not empty, it returns 0, which is false. I'll just write this down. So this is false, it's true. And then we have top and peek, which allow us to get the element on top of the stack. So this get top elements. And as you can see, that the only element we're able to access from a stack is the top element. So we're gonna see an example of how to traverse or reverse a stack using these operations next. So how do we use a stack? It's in C++. The first step is to include stack. It is built in. So after you include it, you can use this keyword stack with the type. So let me use a different color. So this is the type. Let's say it's type int, and then we'll give it a name. Let's call it nums because it's all integers. So this is keyword, this is type, and finally we have the name here. So first step is to use the name of the stack, and then you call in the operation, which is one of the 5 operations that we have. So initially the stack is empty here when we initialized it, and now we want to add an element. Let's say we want to push 1. So, and let's say this is our stack, this is nums. So after running this line, we have 1 pushed here into the stack. What if we push another integer? Let's push 3. Now 3 would be added here, and this would be the top element. So this is one of the 5 operations. Let's call the size operation, which should return 2. Dot empty. This should return 0 because it represents false, and meaning that this num stack is not empty. So this expression is false, therefore it's 0. And next we have top, which returns the top element in the stack, which is 3, and our last operation is pop. And this should update the stack by popping the top element, resulting in just 1 here. And this pop will update the size, update the top, and the following operations. This would be, for example, 1, and this would stay the same because it's not empty, and the size would be 1. So this is how to use a stack. Now here's some practice using code. This is how you can use a stack in your code and be able to use those operations. So first thing, you include the stack and then the type and the name. In this case, I pushed 5 elements into the stack, and the result is let's take it line by line. When we first push 1, then this becomes at the bottom of the stack. We have 3, 5, we need to make it bigger, 7, and the last element we pushed is 9. So as you can see, this is what the stack looks like. The first one pushed in is gonna be the last one to out. So if you remember, the only element we can access is the top element. So what if we want to traverse through the stack? There are multiple approaches you can use, but the most common one is initializing a temporary stack. So this temp is initially empty with a type int. And so in the following lines, I'm just using the operations on the num stack, which we initialize and defined here. So as you can see, the top element, this is printing out the top element, which is 9. The size of the stack is 5 because we have 1, 2, 3, 4, 5 elements. And this one here is printing the expression nums.empty not, which nums.empty by itself should be 0 because this is not empty, but because of the not operator, this becomes 1. So this prints 1, and in case it was empty, it would just print 0. This is very useful when traversing through an array because it allows you to keep looping and keep iterating until it's empty. So as you can see here, we want to copy the elements into the temporary stack, which we initialized. So while not nums.empty, so while 1, or like this means true. So while this is true, while the stack is not empty, temp.push, so we're pushing the top element from nums into temp. So let's say this is temp. What was the top element from nums? It was 9. And then we are popping the top element. So after we iterate again on the second iteration, the top element is now 7, and then we pop 7, and then we push the top element, which is 5, we pop 5, then we push the next element, which is 3, and then 1. And this is all from this nums array. So just by doing this, temp is a reversed stack of nums. And in this is how you traverse through temp. So while temp now, it's not empty. You just print out the top element and then pop, which would give us like 1, 3, 5, 1, 3, 5, 7, and 9. But at the same time, it's also popping it, so you're gonna lose those elements. So this is just one method of reversing the nums and traversing through a stack. And I will leave the link to the code in the comments.